at cookies. Was that a little like sound of happiness? Cookies, awesome. I like cookies. So what are cookies? Cookies are a way for us to store information between a server and a client. So we store information on the client. And cookies have had a bad rap because people have been concerned about cookies and privacy in the past. And if a cookie's been written, in theory, only the website, the domain that wrote that cookie should be able to access that cookie. But in reality, well, maybe other software has been able to read those cookies and get information. Or if one website is writing a cookie, but that website also has ads from some ad server on the website and it writes the cookies, maybe that ad server website, which runs on hundreds of thousands of different domains, could then see, I have written cookies for this user from all of these different domains, and I have a profile of you as a user. So you've just lost information, and companies have gained information about you, and they know out of the 1,000 websites that you go to, they know 342 of them. So they know something about you, and they could start targeting you. So you've lost some user information. So cookies kind of had this security concern, and because of that, anytime you use cookies in Europe, you have to tell on your website, you have to say this website uses cookies. Are you okay with that? And the user has to click yes or no. And if they click no, it's like you have to program some other thing for them, or they have to go somewhere else. You have to say you can't use our site, right? But so cookies allow us to store data because the web and cookies have traditionally been used for sessions, maintaining a session. And this is how we're going to use them. I'm frankly not quite sure how else you would do a session without cookies, except maybe passing some unique ID always through the URL. And so you know every time a request comes in whose it's coming from. Because the web is stateless. So that's where we got to start. The web is stateless. What's that mean, the web is stateless? What is this?
There's no defined shape for it.
No defined shape, but every request from a client to a server is its own transaction, and that's it. So if you're a web server, and I say, hey, can you give me your home page? And you say, sure, here's the home page. Our connection's over. We don't maintain a connection. You serve me the web page, you're done. Right? And that's great because then a server doesn't have to maintain all these open connections and people who walked away from their computers or their computer went off and the server's like, well, I'll keep this connection open. That would be really resource intensive. All a server has to do is basically play tennis, right? It doesn't have to stand there and like hold a phone receiver to its head, which would be an always on connection. You call the server and then the server's holding that phone to its head. In the analogy, you can imagine somebody standing on a tennis court holding 84 phone receivers to their head. That'd be difficult. No, stateless. All it does is a request comes in, serves a response, done. It's like a tennis player on a court. Ball comes over, server hits it back, done. Right? But then another ball comes over, who'd it come from? I don't know. How do we know? Right? Like I log in at your website, here's my username and password, and you go, okay, you're logged in, done. And then 5 minutes later I say, okay, now show me where I changed my password. How does the server know who I am?
By cookies, by kind of like keeping a record of who you are and what your connection is and what you previously did.
Yep, exactly. So I'm the server, you guys are clients. One of you sends me your login credentials. I take that username and password, check it against some data storage, database, NoSQL data store, and then I say, oh, those credentials match a record, a user account, right? I see that you're Jeevjo. I see your Jeevjo, right? And I say, okay, you're logged in, and I send a response to you, and I give it some crazy unique ID. Right? And then I also remember that unique ID is associated with Jeevjo. right? And then we're done. And then he 5 minutes later says, I want to see how to change my password. He makes another response to me, and in his request to me, he makes another request to me, and in his request, he passes that crazy unique ID, right? And then I see, oh, there's a crazy unique ID here. Who does it match? I look through and oh, it matches Jeevjo, right? And then I'm like, okay, Jeevjo, here's your page customized for you that shows, where you change your password. So that would be a session, how we create a session. And so to do that, we have to start learning about cookies. And if you go and you just look on the web, so I don't know, I'll go to Reddit or Twitter, see what's happening in Twitter. My thing is gone. I'm a little sad about it, but actually I feel like it was the right decision. What happens when you tweet and then somebody retweets and you delete it? So delete it everywhere? Yeah. It does? So I come in here and then I look at resources, I think. And then under cookies and Reddit. And here are the cookies Reddit has written. Well, there's a lot of cookies.
Oh, none of those are
confidential.
Yeah, you might want to clear
Reddit session.
Afterwards. Yeah.
Delete this.
Well, log out so that Reddit clears them out on their side too.
Let's just log out right now. Somebody's going to hack me and post on my Reddit account. I'm not concerned about it. Who knows? So let's set a cookie.
So yeah, don't show your cookies off casually like that. If anyone else has got your cookie like that, they can create their own. They can just go to their browser, add that cookie manually, and then and then the server has no way to tell that they're not you.
At 7:04, we'll be blurring that out. So here, let's just run it, and we are in 3201. That's a really nice trick. My cookie, some value. My cookie, some value. So I just wrote that. Cookie. You'll notice there's also session storage and local storage. Anybody know anything about those? Let's hear it.
Those are JavaScript accessible only. So you got some JavaScript running on the web browser. They're able to write to session storage and local storage as ways of saving stuff, which can be useful so they don't have to constantly be asking your server for information, but they also don't have to keep it around in memory all the time.
Could we do sessions with that? Like just write the unique ID via JavaScript and stick it in local storage or session storage instead of cookies, and then we wouldn't have to tell people we use cookies because we don't. We're sticking in local storage or session storage.
Yeah, but then you'd have to get the JavaScript up and running completely, and then that would also mean that if someone else comes to your page, like they want to go to their password page again, it would have to send like almost like a dummy HTML. So if you have a JavaScript then that runs, grabs the information, sends it through Ajax, and then gets the actual filled in details.
It's more complicated.
Yeah, more work than it's worth. Just stick to cookies. It's not really any more secure either. So
I like the dialogue.
Cookies are about as secure as the storage, possibly more secure too, because browsers have been working with cookies for sessions for a long time. Whereas session storage and local storage are more recent.
So here we have handle func, HP handle func. And it's at this route, run this function. And it has that signature, which makes it a handler. And then that's the code which runs. And so we have HP set cookie. And it writes it to the response. And so we have... we take the address of an HTTP cookie, so pointer to a cookie, and we have a name and a value. So we could go look and see what is an HTTP cookie, and we go to GoDoc, and then where? net HTTP.
Oh, you got the place.
And so we could scroll down and we could look for a cookie. Here's a type cookie
Right above the cookie jar.
right above the cookie jar. Type cookie, and a cookie's a struct. It's got a name, a value, path, domain, expires, raw expires, max age, secure, HTTP only, raw, unparsed. So we are using here, we're using a composite literal to create a struct and give the fields values. We're giving 2 of the fields values. We're naming the fields, so we don't have to use all of the fields. So we're saying, hey, name should be my cookie and value some value, right? And then we're taking the address of that, and that gives us a pointer to a cookie, right? So HTTP set cookie, if we look at HTTP set cookie, HTTP set cookie takes a response writer. So set cookie response writer, we gave it a response writer. And why did they ask for a response writer as opposed to just a writer? Because doesn't a response writer, if we look at HTTP response writer, if we look at HTTP response writer, it implements the writer interface. So we could have just said, right, let's set. We could have just said W writer. Why did it specify a response writer?
Well, what makes a response writer different from regular writer?
Well, response writer is this type right here, which is also an interface, but it has these 3. But since response writer implements the writer interface, because it has that method, we could have just said right here, just use a writer. Why did they specify response writer as opposed to just a writer? Does a file implement the writer interface? Godoc.org, OS. And we can look at file. And file implements the writer interface. So if we'd said here, hey, it takes a writer, we could have passed a file there. Would it make sense to set a cookie on a file? That doesn't make sense. It makes sense to set a cookie on a response writer, because response writer is HTTP, how the server responds, writes the response to the client. Okay, so we only want setting a cookie to be written from the server, the response the server makes to the client, response writer. And then it takes a pointer to a cookie.
So if you look at the docs, set cookie is actually a header for the response too. It's not something that goes to the body. So even if it was taking writer, it wouldn't work because set cookie is actually calling the headers function of a response writer, not the write function or method.
How do you know that?
The doc said it right underneath it.
You read it. That's cool. That's why you're on payroll. So it takes a pointer to a cookie. Since it takes a pointer to a cookie, we create a composite literal of a struct, right? And the struct is a cookie. So the struct is a cookie. So we create a composite literal of a struct, give the field some of the field's values, and then we take the address of it, and set cookie asks for the response writer and a pointer to a cookie. So that's how we set our cookie. Sweet! Then we can get our cookie. So we have here request cookie, my cookie. So that's from HTTP request, and we could just do request cookie. Let's go look at that. whole sidebar lights up with request. It doesn't really help.
Request is everywhere.
So request, right here, if you type request, you have a method, cookie. Okay? Because a pointer to request has this method. And we have a pointer to a request, and it's called request. So it has this method, cookie. And what does that method do? It takes a name. Cookie returns the named cookie provided in the request, or error no cookie if not found. So it gives me a pointer to a cookie or an error if not found. 2 returns. So I do my cookie and my error, and then I'm just going to print them out. So cookie will be, if we look at what that does in the code, request cookie, right? It'll return the cookie and nil, or it will return nil and the error. And so here I'll either print out the cookie and nil, or I'll print out nil and the error. And then here's set cookie. It sets a cookie, some value, and listen and serve. So the first time I go here, it'll print nil and an error, and then set a cookie. And the next time I go there, I'll print the cookie and nil, and then set the cookie again. So I'm going to come back to my browser and go to localhost 8080 and open up that and look at my cookies.
After you go to the localhost.
And there's localhost, and get rid of that cookie, clear all. No cookies. And now I'm going to run this, and I am at 3202. Thanks to Daniel for that trick. Go run main. Sometimes the obvious is just completely unseen, and then you see it and you're like, why didn't I see that? So the first time here, refresh, wrote my cookie, and if I look, it printed out my cookie equals some value nil. Name HP run what? Named cookie not present. That's the error. So the first time through, it did that, right? No cookie and then an error, and then my fav icon made a request, and it printed out my cookie equals some value, and it printed out no error.
So wait.
Yeah.
So the first time it ran, it printed out that named cookie not found. That was the first time it ran.
Yeah.
The second time it ran, it was that next one.
Yeah.
Let's do this.
You're not using that serve mux. Just go inside the handle function if URL path is favicon. HTTP error not found, or HTTP not found.
Okay, what am I going to do?
If request.url.path equals favicon.echo. If request.url.
Is it capital?
Rec. Your request. You're being
Request
REQ. That URL.
URL
path
path
is equal to /favicon.echo. HTTP not found. Not handler, just like not found, I believe. This function takes the response writer request. And I don't know what else it takes. Just response writer request, okay.
So,
And then return.
okay, let's run it again. First time, it gave me this, no cookie, and an error. So that first part was nil, error. And then it wrote the cookie, because in my code, it says request the cookie, and then print cookie and error. We had nil and error, because there was no cookie. And then it set the cookie, right? And then the fave icon ran and said, oh, here, and not found. Maybe we would see something over network.
Why do we
saw
call
it.
return here? Why is that needed? Yes.
Yeah.
If we forgot the return, it would say not found, and then it would go down and set the cookie and print the cookie stuff. We need to exit our handler function right there and not continue.
And then If so that's the first time through, and then we refresh this page, we have a cookie now. So next time through it shows the cookie and no error value. Do 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 do. Do 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 do. Anybody know the song? Me either. I'm trying to remember it. I think it's Santana. So this one is show visits. How would we create a cookie to keep track of how many times we've gone to a page? Speculations.
A counter.
Some sort of a counter. You guys want me to leave it as a homework assignment?
Would the counter be on the server or in the cookie?
Where do we keep the value?
Where would you got a counter? Are you keeping the counter in like some big map on the server or in the cookie?
Where do you keep the count value?
Would it be better to keep it on the cookie?
Yeah, we don't want to have it. We don't want to be using a whole bunch of memory on the server, one for every person who's ever connected, and may not ever come back.
So this runs.
I mean, let's running off of App Engine. App Engine's got a really nice memory memcache system.
And we request the cookie. If there is no cookie, so if error equals HB error no cookie, because that's what this returns, right? Returns request cookie,
Like
returns an
262.
error no cookie. So if it's HB error no cookie, Cookie Monster gets really mad about this error. Then we're going to create a cookie, and we're going to say my cookie and the value 0. If there is a cookie, then get the value. Cookie.value. Give me the value. Dot notation, right? This struct and that field. And then string convert ASCII to int, because this is a string. So convert it to an int, increment it, and then set the cookie value equal to string convert int to ASCII. Turn this back to a string and set it back to the cookie value. And then set the cookie, and then write string response cookie value, show the cookie value back to the response. This summer boot camp, I kid you not, man. Like I was about probably in your boat, you know, like, and Caleb would be like, here's how you write a cookie, here's how you set a cookie, now create a cookie incrementer, go. You got 10 minutes. Huh? I feel so slow.
I barely kept up.
Daniel barely kept up.
Caleb's a good programmer.
03203. Yeah, such a good programmer that it was like, you know, this kind of stuff just seemed like, why aren't you getting it? I gave you everything you need. I haven't been programming 15 years. All right. You guys should have been here yesterday. It was awesome. That's like the famous saying in surfing. Talking about summer boot camp like you should have been here yesterday. Okay, so first time to this page, what's going to happen? We're going to get an error, so it'll write a cookie. The value will be 0. And, and then there is a cookie, so we'll take that, we'll increment it to 1. Right? We'll store that. And then we're going to set that cookie, and we're going to print out 1 because it will have been our first visit. 1. My cookie value is 1. We come back, get the cookie, skip this chunk of code because there's no error. We have a cookie. Increment it to 2. Then write the cookie and print it out on the console. Write string back to the response, the value. 2, 3, 4, 5, 6, 7, 8, 9, 10. How is the fab icon being nullified, not being kicked in here? Are we getting fab icons?
Yeah, it's probably session remembering the session. It probably saw the not found the one time, and then it probably cached that not found for localhost. Be my guess. So my guess is that Chrome remembered that it looked at localhost and got a 404 for its favicon not too long ago.
Ah, 5, 6, 7. The first time it went from 1 to 3,
Mm-hmm.
and then it gave up on favicon.
Because that's then a whole another request. So it's trying to decrease the number of requests because it's not HTTP 2, it's HTTP 1.1. So it's trying to decrease the number of requests when it can. So it remembers you couldn't get a favicon only like a minute ago. So
3, 5, 7. So Canary suffers no fools. Canary 50 versus Canary is like the cutting edge 48, so I'm 2 ahead with Canary. That's like the what's coming. You can install Canary just by Chrome Canary. You know why they call it Canary? Any speculations? Yeah, coal mine. Let's see if anything dies. People used to take canaries with them down in the coal mine, and then the bird would die if like the air wasn't good. So the miners would know, oh, we got to get out. Humans, I don't know. We're having chicken for dinner, so what's the point? So I think I'd like to add in, just to get rid of the favicon deal. What would you call that? Like for a comment, it would be what is it when you inoculate or you make something null, not effective? I don't know.
Disregard.
Yeah, disregard. That's good. Disregard favicon requests. And so if request dot path
or
Path.
request that URL.
dot URL Perl dot URL is equal to
Dot path.
path is equal to
So you could do is equal to /favicon.echo, or you could just say not equal to / for basically anything but basic /.
And then we're going to run this code if that's the case, and HTTP not found response request and return. Cool.
There's always a cookie by the time you get to 25. Whether you found one that exists or you created one, cookies exists by that point.
Pretty cool.
Uh, 12 minutes.
Yeah, that's why I was just like hesitating on sessions because there's a big chunk in there. I think cookies is good to leave with. So let's collaboratively come up with the verbiage on your homework.
How many other teachers get to let you figure out your own homework? Not enough.
Do 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 do. I'm sure there's an app out there where I could sing that and it'll tell me the song.
Probably.
Wow, man, it was like a month ago, and still a lot of you guys aren't caught up. What's up?
Not enough downtime. Or crappy internet service.
All right, so we have learned
Cookies and forms, pretty much, since the last time.
request URL path. So let's see. Create a program that displays the URL path using request URL path. And so basically you just recreate this file. Okay, so set content text HTML and then handle anything here and run.
You might use handle func instead of handle.
Yeah, however you want to do it. But you're going to use request URL path. See if there's anything else here. Just playing with request URL path. Request URL path. That's just what you're having me type out to check it. And this one, request URL path. I like this. Use request URL path. Create a web page, and I'm going to change this into web page. Create a web page that serves at localhost 8080 and will display the name in the URL. When the URL is localhost 8080 name. Okay? Capiche? Use request URL path to do this. So that's basically this one here. So you have that. There's just like all the other URL variables you could get. Then we have passing data.
Forms.
And forms. So request URL query get key. That's kind of key value. Do my search, request URL query. I think we'll just stick with request form values. Request form values.
So,
Copy those.
before turning in, you want us to have a link to our GitHub with that code, right?
The file
Yeah.
or folder
Yeah.
in your GitHub that's got that. Preferably folder. If you get if it requires more than one file, get the folder. If it's a single file, then just the file is good.
Alright, and for the first one, do you want us to do the same? Create a web page that serves on localhost 2?
Yeah. It should always be serving on localhost. I mean, if you want to upload it to some DigitalOcean server, you can, but it's easy to just throw it on your localhost and test it there.
Use request form value to do this.
Need to edit that a little bit.
What would I change?
You're displaying the name of the URL when the URL is okay. Never mind. You changed the URL. Got it.
I like that one. So that's basically this file here, but it's going to force you to dig through and find it and use it or copy it. Work with it a little bit. Form values. So this one will be request form value, but grabbing the value from a form. And you could either use your method post or get on that. Create a web page that serves a form and allows the user to enter their name. Once the user has entered their name, show their name on the web page. Use request form value to do this. And that's a checkbox. Create a web page that serves a form and allows the user to upload a TXT file, a file, TXT file, upload a file.
Yeah, it depends on whether you want to print it or save it.
I don't want you to have to check whether it's a TXT, so you do not need to check if the file is a TXT. Bad programming, but just bad programming, but just trust the user to follow the instructions. So your instructions on the page could say upload a TXT file. Once the user has uploaded a TXT file, copy the text from the file and display it on the web page. Use request form file. Request form file and copy, IO copy to do this. So IO copy will take the response, right, that you're going to write. It'll take the response and it'll take the, pointer to the file, whatever you call it. Okay, so you'll open the file, copy the file, write to the response, and then I'll write it onto the web page. That one you don't have a code sample, but you got the pieces to put that one together. Sorry this is all at once, but tough crap. But I've been sick. That tough crap part was a joke. Maybe you didn't feel it as a joke because you're actually feeling a little pissed. Like, what the hell? And then last one, create a web page which uses a cookie to track the number of visits of a user, display the number of visits, make sure that the fave icon.ico requests are not also incrementing the number of visits. So you've got the code on that one. How many people think that sucks? How many people are excited about those challenges? Yeah. You only I mean, I said before that progress has casualties. And you only get somewhere in life through your own good efforts. Like maybe you're a trust funder and you've had it all handled to you, but probably not. And so for the rest of us, you want to build something, get your shovel, start digging, start moving rocks, start doing some sweating, right? And that's how you learn it. That's how I've learned it. I've sweated, I've bled, I've been brought to my knees, figuratively, I've been up late, I've lost sleep, I've lost family time, so I can learn this because I think it's important and I want to know it. And if you want to learn it, you got to get out there and actually start riding the bike. I could talk about riding the bike. I could show you videos and demonstrations on riding the bike, but until you get out there and start wobbling on those wheels and falling off and scuffing up your knees and your hands, you're not going to learn to ride the bike. So be excited. Be thankful for it. I will say one little thing about gratitude because I got 1 minute left. You have all won the lottery already. 7.4 billion people on this planet. You're living in America, right? You're living in the first world. You could turn on the tap water and you could get a drink of water In Cambodia, 1 in 5 under 5 die from waterborne illness. 20% of the kids born in Cambodia die from waterborne illness. You can't drink the water out of the tap in Cambodia, right? We don't live in a war zone. We have shelter. Most of us, I imagine, you all have a place to sleep at night. You got clothes, nice clothes. Looks like you all showered today. Looks like you all had something to eat. And you get to learn. You get to educate yourselves. You have the opportunity to choose your destiny, to advance your skill set. There are people in the world who are living in war-torn nations who love the opportunity to have peace, safety, security, and to be able to educate themselves and learn something. So when you're given work, say thank you. Good. Let me keep going. Keep making me stronger. Keep making me better. Because there's a lot of people in the world out of the 7.4 billion, right? There's only 360 million in America, 400 million in America. There's a lot of people in the world who would love to be in your situation, to have the opportunity you have. So make the most of it. I'll see you all next week.
How much do you know, Tinker?